The equations we move to next are going to contain multiple steps, and we just want to take these very slowly, take our time, always looking at what is being done to the variable and how we can identify it and get it by itself on the one side of the equation. Here we see in this first equation that y has been multiplied by 3 and that 8 has then been subtracted. What we're kind of doing here is we're undoing the order of operations, and we're used to saying, please excuse my dear Aunt Sally. We really want to undo the Aunt Sally and then the my dear to undo the equation. So the Aunt Sally represents addition and subtraction. We want to undo addition and subtraction first before we move on to multiplication and division. So I'm going to undo this minus 8 by adding 8 to each side of the equation. That gives us 3y on the left equals 30 on the right. And now we just have a single one-step equation where we can undo the multiplication by 3 by dividing each side by 3, and we will get y is equal to 10. And we can check that 10 very easily by substituting it in. 3 times 10 minus 8, is that equal to 22? Well, 30 minus 8 is 22, so yes, that does check. Okay, let's do this again. We see that in our equation we have multiplication by -4 and then we have addition of 7. So we're going to undo the addition first by subtracting 7 on each side. On the left we're going to have -4p, and on the right we're going to have -12. Now all we have is one operation there. P has been multiplied by -4. We want to undo that operation, dividing each side by -4, and that will give us P is equal to +3. If you want to check that, -4 times 3 plus 7, is that equal to -5? In a way I should put a question mark over my equal sign. We're testing that. Is -12 plus 7 equal to -5? And the answer is yes, it is. Moving on to number 3 here. We see decimals, but we're not going to let that scare us. We're going to begin by, actually, you know what I'm going to do? I'm going to, since there's only one digit after each decimal, I'm going to multiply through by 10 on each side of the equation. Multiplying through by 10 will remove the decimal and give us 2x plus 53 equals -26. And therefore, there's no more decimals to deal with, and everything's nice and clean. So let me write that down here. What we just did was we multiplied by 10, and that moves all the decimals one place to the right. Had we multiplied through by 100, all the decimals would have moved 2 places to the right. Looking at what we have now, I want to subtract 53 on each side to undo the addition that we see there. That will leave us 2x on the left, and on the right side we're going to have -79. To undo that multiplication by 2, we are going to divide by 2 on each side of the equation, and -79 is not an even number, so we cannot divide evenly, and we just have to leave our solution as an improper fraction. Okay, in the last video I alluded to clearing fractions by multiplying through by least common denominators, and that's what I'm going to do here, and pretty consistently throughout this course or series of lectures online. I'm going to consistently clear the fractions in fractional equations, not on fractional expressions, but on fractional equations, by multiplying through on each side of the equation by the least common denominator, which in this case is 8. Be careful in this problem not to get that problem number 4 mixed in with the problem here. On the left we see that the 8's are going to cancel, and we're just going to have 3. On the right, this 8 is distributing to both of these fractions. In the first case we have 1/2 times 8, which is 4, minus, in the next fraction, the 4 cancels with the 8, leaving 2w. In one pass through our problem we were able to eliminate all of the fractions. Now we look at what we're left with. 3 is equal to 4 minus 2w. That w has been multiplied by negative 2, and then 4 has been added. That negative goes with the 2. That 4 is really a positive 4 that you're seeing there, and so we want to subtract 4 on each side. That will then give us negative 1 on the left equals negative 2w, and then we can divide by the negative 2 on each side of the equation and have positive 1/2 is equal to w, which you can check if you want to. It's a little bit more work to check, but I'm going to trust that the math we've been doing here along the way is correct as we work our way through.